Welcome in, everybody. It is week 8. It is March. It is session 15, and we are talking about production today. We're going to do the number one thing we think you guys should do, and our customers certainly have asked us to do when we're building, shipping, and sharing POCs and prototypes. There's one obvious, clear thing we need to do first, and that is set up production endpoints using open source models. That's what we're going to do today. Let's go ahead and head around the community for just a moment, though. I really want to shout out everybody that was building, shipping, and sharing with their midterm slash demo day projects. My man Anthony continuing to get after it here. I love to see Anthony, to see Ashwin, to see you guys posting the projects. This is something that you want to get in the habit of doing starting now. You'll continue to refine these things. You'll be continuing to build. If you whip up a quick POC and it's a little bit different, for instance, I was talking to Ashwin, he might do something a little bit different for demo day than his midterm. Because you guys, whipping up POCs is not something that's going away. Check out Dr. Dean last week, literally just watching our cursor event, whipping this one up, teaching everybody how to do it on Discord. This is a habit. This is a practice. This is a process we want to get good at. It's not a final end state. It's not an end game. It's not an end aim. Couple quick shout outs as well. I just, I'm really, really excited about how everybody's really supporting each other and getting the fuel and succeeding in the community right now. It's like, I think sometimes you guys forget that we feed off of you as much as you feed off of us. I want to give a quick shout out to The Wiz. Clap, 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 Wiz. He made it into top perspectives on Claude that came out last week, and he's just been crushing it around LinkedIn. He's literally posted every single day this year, and he's on an absolute tear. And really, I hope you can get a little bit from that. If you don't join us for the Monday sessions, I just wanted to share this with everybody. And this was kind of a cool thing too. We had been working with these partners for a long time. Unsloth, we did some stuff with you guys. They went ahead and showcased our video amongst other YouTubers in their docs. And this is exactly the kind of thing that is just kind of serendipitous. It happens if you just build, ship, and share enough. We really hope you guys are sort of getting into that mindset and will continue to crush it yourselves and, continue to help us amplify that we can continue to help you amplify. We're building, shipping, and sharing tomorrow. This was a really interesting kind of storyline with Pydantic AI. You guys are all in a great position to pick up new multi-agent frameworks. So the whole idea is they built Pydantic. Pydantic underlies Fast API. And they looked around at all the frameworks and they said, none of these frameworks really give us that Fast API feeling. Let's build our own. And we're going to see if they actually did it. We're going to see if we like it a lot. Check us out tomorrow. You guys seem to like the class last time. We talked about, you know, the crazy unrolled deep research notebook. It seems like a lot of stuff is coming together for many of you, how everything we've done can be laid out step by step to create something very complex, very powerful. Lot to think about, lot to go through. Shout out to everybody leaving this really, really wonderful feedback. Really, I loved this comment more than any other, I think. I feel like we've hit the edge way faster than I expected. Kind of feels like an awesome roller coaster ride that's ended before I wanted it to. This really is the essence, I think, of what we want you to get out of the boot camp. Is this is an on-ramp. Mike C is sharing every week what's going on in Silicon Valley, online, what's happening at the edge. This is actually what all the VCs, all the entrepreneurs, all the people that run the biggest companies you know of, that's what they do. They just sort of live on the edge. Now you guys are there, you can live there too. It's a decision, and the roller coaster ride doesn't have to stop. We're all going to be on it in the 21st century. So, welcome aboard. And, very cool to see all this come together. Basically just a previous session, but far more complicated, indeed. So I loved all of this stuff. Rate limit, rate limit, rate limit, rate limit, rate limit. Well, turns out that when you try to use the latest model and everybody else is using it, you hit rate limits. And so this is part of the learning as well, is that we want to introduce you guys to stuff like this where it's bound to happen. Like you're not doing anything wrong necessarily, right? It's just that behind the scenes, everybody's trying to use Claude 3.7 Sonnet, especially last week. And so, you know, I'm not sure there was much we could do other than not use Claude 3.7 Sonnet, but we really wanted to sort of get that exposure to the edge. So, I hope that that was at least instructive for you guys. More memes. Shout out to the more memes. Called me out. Love that. Um, this was also a great one. Not sure if notebooks are the best tool. Yeah, they're definitely not the best tool. Actually, that was the whole unrolled idea that we went with last time. Wiz took all the specific individual files from the repo and unrolled them into a single notebook for ease of consumption. So certainly not the best way to ship something and make it easy to navigate. But it brings up another interesting question we got, which was, Wiz, and I'd like you to comment on this. Do we generally start in the notebook when we're going and we're trying to build an open deep research kind of thing? Are we gonna start there in general, or are we gonna go straight into a GitHub repo?
I mean, I, so the answer to the question is yes. Uh, it just kind of depends on your flow, right? So I would personally start directly in an app, but if you're looking to just kind of wind up with an artifact that you can share with others, depending on context, like you absolutely can use the notebook, especially if you're going to be doing some like, well, which component should I use? Which, if you're approaching it from that perspective, then prototyping in the notebook is going to be useful. So it's totally up to you. For the most part, I would suggest start your prototyping journey by starting in the notebook, just because it's easiest to see everything laid out, like kind of line by line. And then as you get more and more comfortable with going directly to the .py files, you know, move at your comfort pace, basically.
Yeah. Love that, love that. And yeah, it always comes down to like what can you move fastest with? What can you do the best work with? How can you be the most effective? And this will come up in just a moment when we talk about midterms. Thanks, Wiz. Also, this type of feedback, this very, very actionable feedback. Hey, you guys should add a graph right here, or we added a graph in our breakout room. We love this feedback because we'll just add the graph next time. So shout out to whoever left that one. Also, shout out to the Agentics. This was the first time look at this. We got no specific individuals called out, but we got two entire groups called out. Love that. Shout out to the Agentics and shout out to the breakout room teams. Crushing it. Okay, let's talk about your midterms, guys. So, first of all, I'm never calling it midterm again. I'm going to call it the certification challenge from now on, so I don't accidentally trigger anybody with bad memories of midterms. The midterm, though, 34 of you guys submitted, right on par with the kind of submissions we're getting for homework. So, pretty much all of you guys. Jacob, what did you see
Yeah.
going through these midterms?
So I graded about half of these. So thank you to Robert and Arthi for kind of picking up the slack. But I saw a lot of great work, a lot of interesting problems people are trying to solve, and then a lot of creativity in the solutions and actually executing it into like an application. And then we also saw it took people 8 to 62 hours. So apologies if you're on that 62-hour mark, but hopefully it kind of sets you up for demo days. So all you gotta do is the storytelling part now, make the presentation, your demo day is ready to go. And so yeah, looking forward to those improvements and iterations.
Now, Jacob, when you guys were going through this, did you notice a quality difference between 8 and 62? Or, was there any sort of like, if people spent more time, are you noticing that they're going into more depth, they're producing a better report, their readmes better? Is there any sort of correlation there, or is it just kind of all over the place?
Um, I would say the people who are like spending 8 to like 20 hours or maybe simply copying kind of Chris's code and kind of implementing it with like their kind of problem. Whereas the people who are like spending 60 hours are like trying to do something truly original. So that's kind of cool to see.
Nice, nice. 62 hours. Smash the chat if you were 62. Now, let's dig into this for a moment, guys, because this is actually really important. And I really want to make the distinction that this is a certification challenge, not a midterm, because it is important. Now, this is the data. Some of you guys reported in days, so we assumed days were 8 hours. Now, we asked you to sort of report the number of hours as if you were billing these hours. So I'm not sure how many of you have actually billed hours as a consultant, as a solo side project, side gig work. But if you have, you probably know that those hours are, a little more coveted than the old day job hours, and you want to take them real seriously. You don't want to be wasting people's money and making them feel like they're not getting their money's worth. So one of the things that I think is real interesting to just consider here. Consider that the average proof of concept that, I've historically done for people, and it's changed with the technologies of AI, somewhere between 5 and 10K. Let's assume on the lower end, it's 5 grand, okay? 5 grand, right? Which is nothing to scoff at, but it's also not going to make you rich. Now let's consider the people that took 20 hours to develop this quick POC. You guys are making $250 an hour if you can get it together and figure out how to share, that is, sell your skills to people today. Now, actually, it turns out 5K, some people laugh at you today. It's actually kind of ridiculous when you only charge them 5K because they think it can't be possibly that good. But you guys are actually doing stuff that really is that good. I'd like to also point out, let's just assume that you're at 60 hours. Well, for 5K, you're making $83 an hour, right? That's $167,752 a year. And by the way, if it only took you 8 hours, you're making $625 an hour. You're on a $1.3 million a year run rate, okay? Just making POCs all day, every day. And I think it's really important to understand this because this is also, again, a low ball estimate for how much people are charging to build systems like this today. If you can't go make the 3 grand you paid for this course back and you finished the certification challenge, like by the end of the year, you're really leaving a lot of juice left for the squeeze. Okay, just that's all I'm saying. All right, so let's just assume we can build POCs. POCs are done. Hype. What happens after we are done with the POC? This is what we need to talk about today. Now, this is the single most famous production GIF that's ever been put out there. You'll notice 101,000 reactions on JavaScript Developer. But I want to really point out here, this is not the everything picture. This is a developer's point of view. Okay, this is a developer thing, right? It's not necessarily an AI engineer's point of view. And of course, AI engineer is not well defined. You see, who builds POCs? Well, people generally outside the company who are working in more of a, kind of researchy consulting capacity. That needs to be passed off to engineering. As the engineers get it, we need to start working with the engineers. The product folks need to start getting it into the hands of users and customers. We need to go from research to more of a product development. And eventually, if we get something that is actually being used and makes sense to scale out, we need to move from a research and development into more of a commercial production capacity. So, this is a lot. It's basically the whole shebang. So what details really matter? And that's really what we want to talk about. We want to kind of dig into this. And we want to kind of understand that when we're talking about production here, we're just building on all of the things that we've been building. And we want to be more practical with the applications that we put out. We want to put our RAG applications into enterprise production, let's say. And so the two things we're going to focus on this week today is endpoints, And then on Thursday, we're going to go deeper into the sort of, I've got it set up, now I'm operating it, what next? And I want to give a little bit of an overview today before we get into the endpoints. Because when we talk about production, it depends in so many ways what we're really talking about. But one way to think about it that's very useful is it means it's running and it's never going down. By the way, make sure you take all of your stuff down today. You don't actually want it in production. We just want to pretend and play. Okay, but actually production costs money. That's why you got to make money. So we want to understand how to shift the focus. We want to understand the importance of setting up private, secure, scalable endpoints, the power of open source. We want to understand how to set up inference servers that can serve up models that we can do inference with, and then build, therefore, very practical RAG applications. When we think about enterprise, we might ask, like, what would enterprise want, right? Well, they want it to be fast, they want it to be accurate, they want it to be cheap, they want it to be scalable, right? Best, fastest, cheapest, most scalable. That sounds dope. Well, I think like that's a limited view. And in general, if we want to sort of meta optimize, what we might think about from a user's perspective is we might optimize by taking stuff away. We might figure out what we don't want our users to have to deal with, or our company or internal stakeholders to have to deal with, and then automate that away. So for instance, it might even be your time later that we're trying to automate away. It's not just about using GitHub. What about your model versions? What about your prompt versions? It's not just about doing evaluation checks. What about automated testing that's set up on a regular basis? What about checking for unwanted content that you might be generating? What about trying to get feedback directly from your users while they're using it? How can you systematically test to sort of prevent that we're getting some sort of drift? This is like classic MLOps stuff. It's not just monitoring. It's also making sure the logs and alerts are set up, making sure that everything is auditable later, especially if you're in a highly regulated environment that's governed by many rules and regulations. We want to be collecting metrics at all the right levels of infrastructure and serving, token usage, frequency of certain failure modes, all this sort of stuff. There are best practices for this. Of course, we can just look for spikes and look for, things that we weren't expecting, look for anomalies. But, it goes further, right? We want to be secure. We want our data to be private. We have PII data, personally identifiable information, that can never, people freak out. That can never be leaked to any LLM. We want it to be able to deal with higher concurrency and peak loads, especially if we're doing a launch and it's going to a ton of people. We want to be able to optimize the cost and the resources and the GPUs and the CPUs. There's all of this stuff that we want to be able to do. And, this is a great meme because a lot of small business customers, they don't need all this stuff, but I'll tell you what everybody wants. They want this. They want their data to be private, and they want you to say it's scalable. Okay, that's what we're going to focus on today. And on Thursday, we're going to go focus on this. We're going to focus on logs. We're going to focus on alerts. And this is kind of that idea of like LLM ops. This is like the first course we ever taught, right? The LLM operation, the ML ops of LLM applications. This is a dated Barbenheimer meme, but you kind of get the idea here. And so like we want to automate all of this stuff. And it's different when we're just building POCs. We want to, just do this exploration. We want to have limited data. We want to only partially test. We want to do ad hoc logging. We want to just locally sandbox it. In fact, that's what we're going to do next Tuesday. That's called on-prem, right? A little local sandbox. And, we want to also make sure that this thing is totally engineered to optimize cost and performance. This is where we get into maybe fine tuning, not just for performance, but maybe just for cost, right? How are we deploying? How many people do I need to deploy to? Am I a CI/CD company? Probably not, but if I am, that definitely has implications here. And so there's all this stuff, and we haven't even gone into any of the details. Luckily, when we look at some of the details, some of the engineering optimization strategies, async, parallelization, database scaling, embedding sessions, well, we've been choosing the right tools for the job along the way. So we just need to give a hat tip to some of the tools that we've already been using. For instance, let's just think about the most basic possible things we can, okay? If we think about requests and application programming interfaces, we might say, how long did it take for a single request to give me a response? Is the idea of latency? Well, I might want to minimize latency, or maybe I want to maximize throughput, number of requests handled per. I'm not going to do the same thing for either one of those. There are sort of fundamental trade-offs. Whereas one, I'm going to put all my resources into getting one thing quick, and the other one, I'm going to put all my resources into doing things in parallel. So if you think about orchestration, we picked LangChain. One of the reasons is LangChain expression language. Look at this, prototypes go to production with no code changes. Things like parallel execution, built in. Things like async and retries, built in. Vector stores like Quadrant that we chose. Well, there's this whole world that now opens up to us when we talk about optimization of inference. When we talk about optimization, either compute or memory, these actually aren't the same thing. We have to learn a little hardware. It also matters, we've talked about quantization, what kind of precision we need. This is kind of all at this level, you might say, of performance, but actually probably the scope and the, security and the goal, they really kind of probably matter a lot more than this. Wiz, I just want you to comment on this for me, please. Um, is this something that everybody's going to have to do all this stuff? It seems like a lot, you know?
Yeah. So the good part is that so the AI engineer is responsible for kind of this stuff, right? So this is the I would say like the low hanging fruit of application design pattern, right? Like we have to make sure the app is asynchronous. We have to make sure that we're designing our programs to be used in such a way that they're parallelizable when that's possible. Like these are just things that you have to do when designing applications. We don't have to do like all of the rest of the DevOps work that's happening behind the scenes. That's handled by teams that are doing AI ops or AI whatever word they're going to use, right, to describe this function. That part, luckily, is likely someone else's job, not our job. But the rest of this, like this other stuff, where we have to make applications that are designed well, right? That's just we're
Yeah.
never going to escape that.
Yeah,
But
like we got to be able to hand it off to these people, right? And
that's
have them
right.
not look at us like the engineers,
Yeah,
the consultants, and say, "Get out of my face! I'm not using your code." Right?
that's right.
You
And
know.
on top of that, like this is largely handled by our selection of the actual frameworks we're using, the way we're implementing things. This is luckily for us, this is largely handled by our choices that were, again, you've already mentioned it, that we've already made, right?
Mm,
It turns out in the background. And then
yeah.
the rest of our crew is going to be handling the hard part for us.
That's right. That's so when you hand it off to the DevOps team who basically already does this all the and you could be one of them if you want, but you just won't be an AI engineer anymore. Is like you want to hand it off in a way that they're like, okay, respect AI engineer, respect. And you want to
Yes.
say the things that they think about, that they know about, that are sort of the basic features built into the tooling that we use, right? I mean, it's like that's how they
Yes.
sell it, right?
You don't want to pass off an application that has obvious horrible slowdowns, right? That like you shouldn't have done up in the first place.
That's right.
Uh, that's not their job. That's our job, right? Their job is to make it run and not go down. Our job is to make it in a state where it can be run and won't go down, right?
That's
Like
right.
that's
That's
the
right. And
it's
so,
a
in short, I guess it used to be when I was in grad school, right? The engineers just sort of made the code work, but they didn't make it work fast, let's say. But now it's like, no, it has to work and it has to be fast so that it can be scaled, right? And then so you want to delineate that line, or you want to pick a side. Some of you I know are already on the other side. So,
yes.
you know, there's a lot here, Wiz. How can I possibly learn it all?
Uh, again, you that's not your job, right? Like that's this is something that you're going to largely be able to exploit the tooling you use to help you with this task. Also, we talk about a lot like in the prospect of getting the job, you want to have specialty, right? But you don't need to have every specialty. So if what you're good at is part of this stack, but not the whole stack, that's enough to differentiate you when compared to others.
Just get in the door. Get in the door.
Yeah,
And by the
that's right.
way, we're talking about enterprise. These SMBs, you can do a lot of this stuff, and a lot of it doesn't matter, and you can just get a lot of experience. But you won't get the super enterprise scale experience. So, it gets more specialized as you get more scale. Okay, Wiz, thanks. We got to keep it moving here. That gets us to scalable endpoints. Or should I say, wait, hold on. I mean, open endpoints. Oh, wait, hold on. I guess I want to put in the language of enterprise, private endpoints. Okay, this is the biggest problem. Nobody wants to expose their data to AI, whether it's Chat GPT, DeepSeek, or anybody else. Nobody wants to do that. Enterprise, small businesses, everybody, they want to ensure their data and their customers' data is safe and secure. Open source models help us do this. Enter, that's what we should offer next. And this is sort of in the shipping category of the old build, ship, share. So we're stonker here. And, this idea is like the LLM and the embedding model that we need for RAG, we should make sure that nobody's looking at the stuff we send to them. And so we picked a tool. It's Hugging Face Inference Endpoints. It helps us solve the problem. We need to run inference on GPU. This is a really easy way to do it. Hugging Face Inference Endpoints. And we think you should just trust us at this point. We'll discuss it more in the coming sessions. This is a GPU solution that is fully managed. Okay, so if you wanted this to be like super safe and secure, you'd have to pay Hugging Face lots of extra money. But there's other ways that we could consider also leveraging open source models. Under the hood, text generation inference is what's being used here. This is an inference engine that Hugging Face has. There are many sort of inference engines we can talk about, and we will talk about as we get into inference optimization more in the coming weeks. But for now, we just want to see how this works. We want to look at models that we want to pull up off the shelf. We've looked at a couple models so far in our tenure together. Let's see if we could take models or similar and set up some scalable endpoints and see what goes into this. I bet we'll see a lot of new trailheads open up just during setup. Wiz, show us how it's done.
Okay,
Mute.
so we're going to go through the whole thing. We're going to start at the end, and then we're going to kind of work our way back. So we will see the end point here. Okay, so we have this Hugging Face space with a Chainlet app. What is the best part of Silicon Valley? We have the old used vector store retriever, and then we're gonna need to refresh because our endpoints have fallen asleep as they are wont to do. The idea is though that we have some app. This app is good at one thing, which is answering questions about Silicon Valley. That's in fact all it's good at. And again, we've made this before. We'll make it again. There you go. The thing that it's powered by, however, is our inference endpoints. So our inference endpoints are these hosted GPU endpoints from Hugging Face. Now, the basic idea here is that, you know, all models, the whole time we've been using them, need GPUs in order to go burr, right? They need some hardware that they're running the LLM on that we can then consume through some kind of endpoint. So like we've been using OpenAI, right? And if you look at the actual API documentation for OpenAI, if we look at the reference that they have, right, we're going to see that there is some uh, endpoint here. HTTPS API OpenAI.com v1/models, right? So this is the idea. This whole time we've been hitting this endpoint. It's been kind of like obscured because we're actually using we're using the SDK, this Python client, right? That lets us do this easily, and then even further, we are going to use LangChain, which wraps the Python client, right? But the idea is that at the end of the day, it's a request to this endpoint. This endpoint hosts the model API, right? So behind this endpoint exists some kind of model that's running on GPU. The idea is we want to do this without doing this. We can't actually run the model. So how do we get a GPU right in the cloud? Well, the idea is that there's a number of model providers that help us do this. You'll notice we're using AWS here, and what we can do is we can rent a GPU from AWS, and then we can use that GPU to run our model. Okay, all of this hopefully straightforward, hopefully making sense. So let's look at how we actually set this thing up, and we're going to talk about some gotchas and stuff along the way. So the first thing we're going to do is go to Hugging Face. We'll just go to whatever huggingface.com space. We'll refresh this and see if the endpoint's woken up. It has woken up. This is great, right? So we can see the app work and we can see the tokens being generated. They're just being generated by the model that's running on that GPU we talked about. Very cool. Okay, we can see that it used some stuff. Neato bonito. Let's go to Hugging Face though, and then we're gonna go to this drop-down menu, and we're going to go to solutions, and we're going to go to inference endpoints. So inference endpoints. And then we're going to see our inference endpoints. You can see that I have many paused inference endpoints, and you can see that I have 2 running inference endpoints. You can guess kind of what those are going to be. So the first one we have is our model endpoint, and then we have an embedding model endpoint. Let's create the model endpoint. So what we're going to do is we're going to point to new research, Meta Llama 3.1 8B instruct. Okay, so why are we using this weird, checkpoint? Why not use metas? Basically, you have to sign up to use metas on Hugging Face. If you haven't done that, it could take 2 to 5 minutes. So new research is open. There you go. There you go. Okay. We're going to name our endpoint. Let's just call it like AIE5 demo V1. And then we're going to choose some hardware. Now you'll notice that it's trying to get us to go on a CPU. No shot. No shot. We're going to go to GPU instead. We're going to choose the smallest GPU that fits, which is going to be our L4. So that's got 24 gigabytes of memory. We could technically use a T4, but it will be a horrible experience. So we're not going to use the T4. All of these T4, L4, A100, A10G, L40S, these are all different kinds of GPUs. The only thing we actually care about is twofold. Number one, how many GPUs, right? So the one we've picked has 1 GPU. 2, the amount of total storage or GPU memory, right? So we need to pick a set of hardware that allows us to fit our model on that set of hardware. So what we need to do is make sure that we're using, in this case, at least 24 gigabytes, and then that's it. So you could use this L40S with 4 GPUs, 192 gigabytes, and your model is going to be able to both run very quickly and handle many concurrent requests, as well as really long context. Or you can go with the L4, which is going to be good enough for what we're doing today. But this is the idea. And this is when you're using managed service, right? This is as hard as it needs to be. That's it. You pick the one that has enough room to fit your model. That's it. That's all we need to care about, right? Nothing else. As you get into more and more complex setups, right? This becomes more and more of a problem, let's say. However, as it becomes more complex, you're going to be passing this off to teams who specialize in it. Okay, so let's just choose the L4 because it's good enough. And then for auto scaling, we're just going to go to after 15 minutes with no activity, scale down to 0. The maximum number of replicas, which is like how many instances of this container, right, which we're going to talk about in a second, it can be running at a time. We're just going to choose after 15 minutes with no activity, we're going to scale to 0. You're not charged on Hugging Face for paused or not running hardware, okay? You are charged every single moment that's running. So I'm going to say this now, and then we're going to say it like many more times. Please, at the end of the session, be sure to turn your endpoints off because you're just going to keep getting charged for as long as those suckers are running. So this is like one layer of protection, but it's one small layer of protection, right? Not enough. We're going to shut them down manually. We're going to use protected endpoints. This just means you need your HF token. We already have one. Easy. Then we're going to go to container configuration. Container configuration, very straightforward. What container do we want to use? We've got a couple options. We got TGI. That's like, Hugging Face's bespoke inference container. We have custom. We have default TGI. And then we have some others that we could use if we were engaged in enterprise level Hugging Face services. We are going to use TGI for this. This is Hugging Face's inference solution. It's basically a Docker container that does one thing, and that is make the model do inference. And they've done some level of optimization. The optimization itself is makes the model okay, right? It's not like the best though. It's however a good middle ground. So we have two different sections two different things we can think about when we're talking about inference, right? We can talk about latency. How fast can we get tokens back? How quickly are we getting that response back? Then we have throughput. How many can we handle at once, right? Can we do like 40 different requests at the same time? That's going to be our throughput, right? TGI is a good middle ground. It's not very good at inference or latency. It's not very good at throughput, but it's not bad at either of them, right? If we want to go like, throughput heavy, things like NVIDIA NIM exist. If we want to go latency heavy, things like VLLM exist. So we have options. In terms of this tonight, though, we're just going to stick with TGI. It's good enough. We're going to enable custom CUDA kernels, and we're going to enable quantization of bits and bytes. We already talked about quantization with bits and bytes. This is doing the same thing, but inside the container. The reason we choose this is because you'll notice we selected an 8B model at the top, also answering someone's question about where do we select the model. It's right on the top here. We pointed at the model checkpoint. 8B does not fit on 24 gig in full precision, right? So we need to shrink it down. We need to use lower precision. We need to use bits and bytes. Okay, then we have this stuff. We're going to fill this stuff in just based on the example we're using. The screenshots in the repository will tell you what numbers to put here, but the idea makes sense, right? What's our maximum input length per query? What's the maximum number of tokens per query? What's the max batch pre-fill tokens? Pre-fill is this phase that happens before we do inference, right? So it's how much can we pre-fill into GPU memory before we start chugging along. And then our max batch total tokens is how many tokens we have total in a batch. So we're going to set these up when we create our endpoint. Again, the README is going to tell you what numbers to put there. But you can imagine that this is a more thoughtful decision once you're quote unquote going to prod. Okay. Once we've done these steps, picked our model, named the endpoint, picked our hardware, right? Made sure that it says after 50 minutes of no activity scale to 0, selected a protected endpoint, and made sure we've enabled bits and bytes and filled out these boxes. We click create endpoint, and that's it. That's the whole process. We wait, and then we have a model. The model is ready to go burn at a moment's notice. You're going to see that we're going to get charged for this based on our hardware. Again, if it's paused, right, we are not going to get charged, but we are going to get charged if it's not paused or deleted. So what I'm going to do is I'm going to walk you through how to delete it, which is we go to settings under endpoint, we go to delete endpoint, and then we just copy and paste in the name, and that's going to go ahead and nuke that endpoint. Goodbye, endpoint, you're gone. Okay, we can also look at like our usage dashboard, right? So you'll notice that we have some number of requests. We have some number of replicas that are either ready or not. We have pending requests. How much of our CPU are we using? How much of our memory are we using, right? How much of our GPU memory we're using. You'll notice we're using quite a lot of it, even though we've quantized the model. It's still big, right? So it's taking up 20 out of the 24 gigabytes. There you go. We're also looking to be able to see our usage and cost, as well as our logs in case things go wrong. The idea, though, is pretty straightforward. Once this thing is running, it's running. We're going to look very briefly at our embeddings API that we set up, which is going to run the Snowflake Arctic Embed Medium model. We set it up in a very similar way. So we're going to go to, Snowflake, but imagine it's spelled right. Snowflake, Arctic Embed M. We can name it whatever we want. We're going to once again choose a GPU, though we can choose the smallest GPU for this particular embedding model. Make sure auto-scaling is set up. In our container configuration, we're going to make sure that we're set to mean pooling as our pooling method. This is just a quirk of the thing. This is what we want. We want mean pooled embeddings. We talked a little bit about pooling when we talked about embeddings. And we're going to use TEI instead of TGI. You can imagine it's the same thing, but for embeddings. So it's fast embeddings. Also, in our more options, we just want to make sure that this says sentence embeddings. So we want to make sure that task is for sentence embeddings. It should still work if you don't select this. You don't have to worry about it too much, but this will ensure that it works most happily. But that's all you do. You just have to set up the endpoints. This is it, right? This is where our job would end. We've got the thing running on some hardware, right? We can go back to the to the space here. So we'll go to our Hugging Face, go to our profile, go to our spaces that are running. We can see the space here and say, how do I be successful in a startup, whatever it is. And then we're going to use a vector store retriever. We're going to use the model, and it's going to give us a response at some point. There you go. That's the thing. It's easy. Setting up endpoints couldn't be easier. It's just going to take a little time. So I will say you can expect that you're going to have to wait for this process to finish, but the actual process of setting it up is very straightforward. And you can imagine you can just choose bigger hardware for bigger models, and that's going to work for you. Okay. With that, I pass back to Greg.
All right.
So we can get into
I got a quick cue, though.
Yeah, of course.
So I think Delay wants you to double click in on quantization. So I think you probably selected a quantization technique here. That is
bits and bytes.
That is a lovely trailhead, let's say, to the inference optimization thing that we're going to do. So you have different selections here when you do this quantization. AWQ, oh, look at that. Oh, we'll be talking about that soon enough. GPTQ, right. We'll be talking about that soon enough. Why did you not select bits and bytes NF4?
So this goes back to our hardware. So if we look at our hardware, right, which is going to be the 24 gig, basically the 24 gig GPU will fit the 8B model at the standard bits and bytes quantization, which is going to be 8-bit with 4 gigs left over. That's going to let us have sequences up to 8K, but we're just going to limit it to 1K for the example. All on one GPU. It's going to make sure we're using as much of the GPU as we can, right? If we use, say, NF4, we're going to trade some quality, and we're going to have more space on the card, but we're not going to take advantage of the space, right? There's got to be like this unused space. So why not use a slightly higher precision, right? Well, not slightly. Why not use twice as much precision, right? In order to, because we're using int8. And then we're fully utilizing our card. There's actually a really good blog that was just done by the peeps at Modal, which is another GPU provider. which I'll link, which is about GPU utilization, right?
That's right.
So
That's right.
the idea is that we really want to make sure we're using the whole card. Uh, we don't want to like have just waste because we're paying for the whole card, to be clear.
Right.
They're charging us for the 24 gigs. They don't care if we only use 10, right? So and this gets into a deeper conversation, which we're not going to have in depth, but we can in office hours, which is right sizing your hardware to your model. And you'll also, if you're paying attention, you'll notice like models come in weirdly similar size ranges, right? Like we have a lot of 7 to 8.5 billion parameter models. We've got a lot of model sizes clustered kind of around the 70s, right? We got a lot of model sizes clustered around like the 3 to 4 hundo range, right? This is because those sizes fit really well in different profile hardware, right? That's the point. It fits real good on an A100 node if you've got your 8 billion parameter model. And so this is an artifact of the hardware that these models have these weird clusters of appropriate sizes.
That's right. And there's always this optimization we must do. Ben brings up a good point. Higher precision slows down inference. Yeah, it's like the iron triangle of project management. If you guys have ever studied that, it's like you can't have quality and speed and cost all the best. It's just like that's just the reality of life. So you gotta decide, okay, what's important to me, what's important to my team, what's important based on the resources we have and our constraints. That's how you solve any optimization problem. By the way, join our optimization series that we're kicking off next week. All right, with that, we're going to get into our first breakout room. There's obviously a lot that you guys can talk about here, but let's focus in on the endpoints. Set up the LLM endpoint, set up the embedding model endpoint. If you have questions about the setup, ask away. And we will be coming back. It'll be about 10 after on the hour, and we'll take a break then. Enjoy your breakout room with your journey groups, guys. Endpoints. Let's go.
Let's freaking go.
Keep them up, but then shut them down later. Shut them down later. Okay, shut them down later. See you back soon. And we're back from breakouts and from our quick break it out, shake it out. I just would like you guys to just recall where we began this course. And we've talked about a lot of stuff, okay? We've talked about all sorts of stuff as we built, shipped, and shared LLM apps. When we have a model, we want to do inference on it. In order to do inference, we have to have it served up somewhere. And, when we do inference, we're doing it on these GPUs. And when we're prototyping, it means we're making it run when we have to. When we're doing this production thing, we want it to be running and never going down. Of course, today, we want it to go down when we're done. This is sort of looking at the inference piece is what we're kind of doing today. But we're starting to break apart the utility of the LLM app stack a little bit. Remember, we talked a lot about this already. This is sort of the inference piece of it here. But you'll notice also we're hosting an embedding model as well, which isn't in the inference stack, but we're still doing inference on it. So you can start to see that nobody's frame is perfect here. And we all have to sort of use the patterns and leverage them as we see fit. Today what we're going to do is we're going to go ahead and focus in on building a full open source production grade RAG application with some toy data, sure, but with all tools that will scale up and be useful to you guys. Let's call it the enterprise RAG application. And this is something you can sell. I have sold this myself. We've got people that have come through our course and sold exactly the same system, copy paste the code, just like you guys did on the certification. This is something you can make that sweet, sweet cash, just like we were talking about earlier with. If you can do this, if you can set this up, if you can go open source with these models, and you can build this with somebody else's data, keep it safe, and maybe just work with somebody that's not so freaked out about the data first, then you're going to be in a very, very good situation heading into the rest of the year here. So Wiz, show us how to put it all together, knowing everything we know now. Full stack, end-to-end, open source, production grade, enterprise RAG. Let's go.
Let's go. Okay, so the first thing we're going to do is I'm going to share very quickly how we would do something that someone asked during the break, which is how do we get our own embeddings? Let's say we fine-tune some embeddings and now we want to run them on an endpoint, right? So what we have to do is go to our repository with our embedding model that we fine-tuned. We're going to copy the ID. When we create a new endpoint, we're going to go ahead and paste that in, and that's what we have to do. So as long as it's on the hub, you can point to it in this model repository section, and as long as you've pushed it to the hub from your notebook, you'll be able to do this. And that's it. So very straightforward, useful feature. Okay. Once again, we have some endpoints that are running, our embeddings in our demo. Very cool. We're going to do a notebook here. The notebook is basically just going to have our actual, the app that we're going to be building, right? So we're going to get some requirements. The requirements are going to be pretty straightforward: LangChain Hugging Face, LangChain Community, Face CPU, and then Hugging Face Hub 0.27.0. It must be this version. If you're using this locally, you don't have to run these pip installs. The Pi project will have you covered. We're going to pass in our Hugging Face token now instead of our OpenAI API key, because we don't need OpenAI for this one, because look at that. Our endpoints are running on Hugging Face. Then we're going to provide our LLM endpoint URL. The way you get this is you go to your LLM model, right? You're going to go ahead and hit copy on the endpoint URL, and then you'll just paste it in right there. And that's going to be your endpoint URL. Now, you may, in the notebook, I believe there might already be an endpoint URL. Please override it with your endpoint URL as you get from that process. You'll notice that we have a bunch of parameters here, which is how many tokens are going to generate, what our task is, the actual endpoint URL, as well as some other, classic, let's call them, generation parameters. And then we can ping the LLM by just, using .invoke like any other LangChain runnable with a string. The string is going to be passed into our model. Our model is going to get the request. Our model is going to process the request. And that's what's going to be going on. So if we look at the actual requests coming in, we should see that request pop in as soon as it's done processing here, which might take a moment. This is the first generation I'm doing on this particular endpoint. Once we're done with that section, what we can do is set up our RAG prompt. Now you're going to notice something a little bit strange here, right? So we have, there we go. We have the extremely verbose output of how the LLM is doing. You can see that it spit out the response. And then if we look at our requests, we can see that we had a request and we filled out the request. And you can see that the latency was quite high because, again, that was the first call for this endpoint. Once we have our model set up, again, we're going to set up this RAG prompt. But you'll notice we have like this absolutely weird looking, token sequences. Now, this is because the endpoint doesn't come pre-cooked with a system, assistant, etc., prompt mode. So what you have to do is provide that through the prompt template. So again, behind the scenes of our model, right, behind the endpoint, this is what's happening. Our model only ever takes one big block of text, right? It doesn't have like multiple inputs to it. It just has its context window. And so we're going to do this manually here with our start header ID for system, and then our end header ID, then our start header ID for user, and then we're going to use our end of token ID, and then we're going to use our start header ID for our assistant. This is going to be the thing that prompts it to respond as the assistant. Very cool. That's it. In our prompt, we're going to have our user query, which is going to be query and their context be context. And then we have our classic boilerplate, your helpful assistant up here. Then we're going to create a chain. The chain is going to go from the RAG prompt to the LLM. And then we can use, we have to click, of course, play all the way down. But we have the idea of our RAG prompt then is going to be populated by query and context. So if we look at this in actual factual land, remember that this is going to be replaced here. And then this is going to be replaced here. So we're just going to format just like normal, right? It's just regular old RAG. But this time our LLM that we've hosted on this endpoint is going to be the thing that gets the request and then passes it off. Very cool. We can do the same thing, with the embeddings model. So we have to go to now our embeddings model. We're going to go back to the dashboard. We're going to go to our embeddings model. We're going to grab the endpoint URL from endpoint URL here. We're going to paste it in, and then we're going to paste it in, and then we're going to press play. Once again, you're going to want to use yours. Please don't use mine. Once we've done this, though, we are good to go on. The way we're going to go on is by just doing simple cosine similarity. We're going to have this phrase, I love my fluffy dog. I adore this furry puppy. See how related those two are? We see that they're quite related. And then we're going to have, I love my fluffy dog. Trekking across the Arctic is tough work. Less related. Indeed, those sentences are not as close together as the others. This is easy stuff, though, right? It's literally just replacing what we normally use OpenAI with for this Hugging Face embedding, right? That's the new thing. And then from this is just regular old RAG. You'll notice that we have this weird setup for our embeddings. This is to avoid potential issues with the endpoint, which has some batching restrictions at batches of 32. So basically, we're only able to process 32 chunks of documents at a time through text embedding endpoint through Hugging Face. And so we're just going to loop through our documents in chunks of 32 to do these. We could use asynchronous patterns here to make the requests fire off faster. But because the endpoint's hosted on the minimal hardware, it will just take a long time. So the total amount of time that we're actually spending is going to be roughly equivalent, regardless of if we do this synchronously or asynchronously. Just a product of the fact that our endpoint will actually let responses queue and then take a long time to get through them. So we're going to be waiting this time anyway. So this is how we do it. Then we set it up as a vector store. This is a limitation of the Hugging Face endpoint delay. Then we're going to have our simple LCL chain, classic RAG chain. Boom. What is the best part of Silicon Valley? The best part of Silicon Valley is not the physical buildings, but many startups were there. There you go. Very cool. That's really it. That's all we got to do, right? We're going to then appify. Now, the appify process is going to be a little bit more involved. There is detailed instructions in the repo on how to do this. I'm going to show you those detailed instructions, and I'm going to be very clear about something that your peer supporters are also going to be very clear about, which is that in session 15, in our repo, we're going to have this application start folder. This is going to be where you build your application. Do not do this in your main AIE5 repo, or you will have a bad time with Git. Please do it in a new repository, right? So when you create your Hugging Face space, right, let's go to Hugging Face, let's go to spaces, let's create a new space, right? When we create this space and we get the SSH address, we're going to do this in a new folder, and then we're going to copy the contents of this folder into the new folder. Nice and easy. We've got a Docker file for you. We also have the app.py, which again is going to have detailed instructions on how to build this thing. But what also exists is a solution that you can look at that will show it to you if you get stuck or have questions. The solution is not it's not de facto the best way to do it, right? So as long as what you do works and is effective, please do that. But if you want the solution, it's provided for you there. That's really it. Just creating the open source RAG and then appifying it with Chainlit and pushing it to Hugging Face space. So you have a Hugging Face space talking to Hugging Face endpoints, all open source or private. Very cool, very awesome. We'll pass it back to Greg, who will get us into breakout rooms.
Very cool, very awesome. Enterprise RAG. We got a solid 25, actually, I think we've got here. Let's go ahead and get started with it. To create the RAG chain, and then, you guys bring in the skills that you have here. Imagine you're doing this for a client. Imagine you're getting paid big bucks and you can get it done in 2 hours. Create a Chainlit or maybe a React front-end app. You guys know how to do that now. Deploy to Hugging Face or wherever you want. You guys know how to do that now. So, there's the app level that we'll talk about more next time. we're at the LLM endpoint level that we're talking about this time. But sort of as we abstract more and more, we sort of go more and more into this space where it's shareable, it can be used and easily hit from somebody's production environment. And so think about all of these skills that you've developed. If you're sort of done with the endpoints and you get them integrated and the RAG goes pretty quick, see what you can build, ship, and share. 25 minutes. See you back to close out our first production session. Round it out. All right, guys. We set up open source, private, scalable endpoints. That was awesome. Now, don't forget to shut those things down right now because they will keep charging you and they will keep taking your money, okay? And it's officially not our fault. Public service announcement. All right, so please shut them down. If you've ever had a bad experience with AWS, you're about to have another one if you don't. Okay, that's all. Remember, production means running and not going down. So we want to deploy our RAG, our agent applications to production. We want them running and not going down when we want them running and not going down. You guys have to figure out, okay, what is it that my customer, that my enterprise, that my small medium business needs? What level of scalability, of testing, of automation is really necessary? Today we talked about how to get a little bit more security and privacy, a little bit more scalability. Next time we're going to talk a little bit more about LLM ops, looking at those logs, those traces, setting up things like alerts. There are many, many things that are actually table stakes for production grade apps today, and they're built in to the selections of apps that we have given you guys. So when you go and people ask, hey, why did you choose that one? You can basically like kind of go back to the feature pages of them and just sort of say like, oh, well, it's async out of the box and it's got parallelization like baked right in, no code changes as I hand it over to you, DevOps team, to put it into production. Remember too, if you're buying GPUs, you want to utilize all of them. This is a little bit of a, a little bit of a sort of trade-off thing to keep in mind. And there's always an iron triangle between quality, cost, and speed in everything. And make sure you turn off those endpoints. Okay, so with that, come around, see us this week. Come around, see us tomorrow to talk Pydantic AI, or check it out later if you're busy working, like most folks. Don't forget that we are going to be in just a couple of months in Toronto. Join us there, live, in person. We'd love to have you help peer support the workshop as a certified practitioner. And it's feedback time. Let us know what you thought about the first production sesh. We're talking LLM ops next time. 2 minutes. I'll owe it back to you. Promise to give it back sometime before demo day. All right, guys, thank you so much for joining us for session number 15 out of 20. We've got 3 more sessions proper of curriculum to cover: LLM ops, on-prem agents, and inference optimization. And then we're going to really, really focus in for an entire week on getting our demo day stuff ready to rock and roll. So spend as much time as you need with these production ideas. Come to office hours, talk to other folks. If you don't have an engineering background, it's a great opportunity to start exploring some of this. If you do, maybe you can do a little bit more work on your demo day project. But keep us posted, keep building, shipping, and sharing. Share those midterm projects. There were 34 of them, and I only saw 2 shared. Tag me, tag at AI Makerspace. We'll see you guys on YouTube tomorrow or in class on Thursday. Have an awesome week, and we'll see you for session 16, LLM Ops. Bye, guys. Have a great evening. See you soon.
Bye,
Sure.
everyone. See you Thursday.
Bye, guys. Woo, 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 woo. Woo, 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 woo. Later.